We've looked at energy from fossil fuels, so let's move forward and talk about how we're going to replace those fossil fuels with alternative sources.
Dependent on electrical energy. Previously, we covered energy from combustion of fossil fuels, which contribute to atmospheric carbon dioxide. Our use of all kinds of energy is increasing dramatically. How can we replace our combustion-based sources of energy and expand to meet our future energy needs? In this chapter, we'll discuss some of these energy sources.
Renewable alternative energy sources are important not just for replacing fossil fuels that are generating greenhouse gas emissions, but also we can actually solve two problems, greenhouse gas emissions and climate change, but also air pollution will be solved for switching to these renewable sources. So we're going to get into solar power, exactly how solar panels work, what exactly hydroelectric power is, as well as geothermal, and then a lot goes into talking about nuclear reactors. Nuclear reactors are controversial. That's generating electricity for the grid using nuclear energy. Nuclear energy was the fifth major type of energy that I mentioned back when we were talking about energy forms, that we don't usually see it because you have to break an atom open. Over the long run, the sustainable energy source that has the greatest potential to meet humanity's energy needs is solar. We do need to get solar panels, and that has a startup cost. So we have some other large energy producing like nuclear, which is promising but has its issues, as well as we'll get a little bit into nuclear fusion, which is very promising but also has issues. So solar power, this is energy generating electricity from sun. And the sun's rays hit Earth every hour all over Earth. So just focusing on the U.S., the southwestern U.S., this is Arizona, New Mexico, parts of Southern California, lower Utah, this is lower Nevada. This is where we get the most amount of sun in just the United States. So it is conceivable to take a lot of solar panels and install them here. Now there are cities there like Las Vegas, Phoenix, but this is something that could definitely be utilized, is installing more solar panels in this region and taking advantage of the energy from the sun. Solar panels contain photovoltaic or PV cells. And these convert sunlight, which is radiant energy, okay, so it radiates as a wave, and this converts this radiant energy into mechanical energy if it's this type of system that is called solar thermal, okay? So this takes the energy from the sun and uses it to heat up water. Okay, and this is similar to the process of a coal-fired power plant when you heat up water and run it through the pipes, the steam causes a turbine to rotate, and then that turbine rotates a generator that'll generate electrical energy for the grid. So this is solar thermal, where the energy from the sun is collected, the heat is collected and used to heat up water. Now this is an example of solar that is directly producing electrical energy. So these same photovoltaic cells will take this radiant energy and directly convert it into electricity. And so we'll look at what goes on in a photovoltaic cell. This is a solar array in Germany. Europe actually has quite a bit of this going on for solar energy generation, and Europe is one of the leaders. So you just take a plot of land, you put a bunch of solar panels, boom. So this is direct, there's no water heated up. And I should mention that solar cells, photovoltaic cells, don't have to be large. If you have a solar calculator that's powered by light, you have a very small PV cell in your calculator that's generating electrical energy that runs your calculator. And so this can be small. It doesn't even need sun. It just needs light energy hit. At the heart of whether it's a small solar calculator or many photovoltaic cells in a solar array, The photovoltaic cells all work the same way, and silicon is an important part. So we've talked about silicon before. It's a metalloid. On the periodic table, it's the element symbol Si, and there is a silicon in every photovoltaic cell. So here's at the atomic level looking at silicon atoms with their valence electrons. And so there are silicon atoms, and in the cell, when it's hit with visible light, so that is visible light, that is energy, that we can break down energy to packets that are called photons. So those are small units of energy when you think of energy as a particle, but energy is also a wave, so visible light. So this is light hitting the electron that causes an electron to move. So in another layer in the photovoltaic cell, you still have silicon atoms in another layer, but here it's doped with a different atom, which is an arsenic atom in green. Okay, so this arsenic atom actually has an extra electron, and that extra electron is something that is free to move and can move if you have another layer adjacent that has still silicon, but has another different element in here, which is a gallium atom. Okay, so this is mostly silicon but with a gallium, and this is mostly silicon but with an arsenic. This layer has an extra electron, and this layer has one less electron, a missing electron, or a hole. Okay, so what happens is when these two layers are adjacent, when an electron is hit by a photon and moves, such as here, this electron will move into the easiest spot, which is a hole in the adjacent layer. So this is showing those layers when you have two layers of silicon, where this is the silicon that has extra electrons in it because there are those extra electrons from having a different element in there that's not silicon. And then there's another layer of silicon but having a few atoms that have less electrons. So these are two layers adjacent, and these electrons in the extra electrons will move into the hole in the adjacent layer, and that only occurs when sunlight hits it. So remember, the definition of electrical energy, of the 5 major energy types, electrical energy is due to a motion of charges. So this could be a motion of electrons. So as electrons move, this is generating electricity, and this will go directly, this is direct generation of electricity to have your light bulb or your calculator or electricity for the grid. We know that these solar panels have these exotic metals that are expensive to produce because we don't just easily have silicon lying around in its pure state, nor gallium, nor arsenic. So those all have to be processed, and this is quite expensive to generate a photovoltaic cell. So this is also not entirely efficient. Even though sunlight is free, this sunlight, the conversion to radiant energy, the conversion of radiant energy to electrical is only about 21%. So though there's nothing wasted because sunlight is free, there is that initial startup cost, and so there's that to consider, which is maybe the reason why not every single home in the world has photovoltaic cells. So there are rare metals. These are also can be easily broken. They don't need much maintenance, but you do need sun. So that was why we had the initial map showing that you need to put these solar cells in areas that get lots of sun. You need land and space. For the U.S., the energy needs to cover the U.S. would have to be the size of New Jersey. That's not a lot of space, but it is significant, the size of New Jersey covered in solar cells. Okay? Since we know, though, that having solar cells, using solar energy could potentially meet all of humanity's needs in countries all over the world, we still think of it as a great possibility for the future. There's no carbon emissions, there's no air pollutants, and you can use this off-grid. So that's what this is showing, is even without having any hookups to electricity, you can put a solar cell just about anywhere and it'll generate electricity. This is showing, let's just incorporate, instead of having separate solar panels, let's just incorporate them into roof tiles. That's a great idea. And small photovoltaic cells can actually become very common in homes. It doesn't have to supply electricity for the entire home, but at least some if we start incorporating in roof tiles. One thing is known is that every country has some sun. And so this can at least replace some and be a renewable and alternative source of energy that is not carbon emissions